Good morning, students. This is Lailpur Khalsa College of Engineering, Jalandhar, and today we discuss our next unit, differential equations and their formulation. So, to discuss this unit, differential equation and their formulation, this unit involved the concept of differentiation as well as the concept of integration. So, to to gain the good knowledge of this unit, you can remember what is our derivative, what is the concept of integration. So first of all, today we discuss the introductory part of differential equation. To discuss the introductory part, firstly we discuss the meaning of differential equation. So an equation which involves the differentials or differential coefficients is called a differential equation. So any of the equation which involve derivatives, differential means derivative or differential coefficients. Differential coefficients means dy over dx is our differential coefficient. So any equation which involves the derivatives or differentials or differential coefficients is called a differential equation. So for example, an equation of the form dy over dx equals to x plus 3 cos x, because this equation involves a derivative. Derivative is dy over dx. So this equation is known as a differential equation because this equation involves a derivative dy over dx. And also here there is a one dependent variable y and x is our independent variable. Y is dependent variable and x is independent variable. So let us suppose one more example, d square y over dx square plus 5x dy over dx plus 7y equals to 0. This equation also involves the derivatives. D square y over dx square is a derivative, dy over dx is a derivative. So this is one another example of the differential equation. For we discuss the next example, y square dx plus x square dy. This is also a differential equation because this equation involves a derivative dx and dy. Dx means derivative of x, dy means derivative of y. So differential equation is simply an equation that involves a differential coefficients or derivative or differentiation. So this concept is basically introduced because the differential equation has a number of application in a many fields of engineering and science. So first we discuss the differential equation. Now we discuss after differential equation the different types of the differential equation. First we discuss the first type of the differential equation is ordinary differential equation. So ordinary differential equation is a differential equation which involves only one independent variable or ordinary derivatives. So the differential equation which involves only one independent variable or the ordinary derivatives is called a ordinary differential equation. So these are the examples of ordinary differential equation because here there is a one dependent variable and one is only one independent variable. So these are the some examples of ordinary differential equation. Now partial differential equation is the equation which involves two or more independent variable and partial derivatives. A differential equation which involves partial derivative. We know that our partial derivative is represented by curly y over curly x, curly y over curly z. So if the equation involves the partial derivatives, then the equation is known as a partial differential equation. So first we discuss differential equation. Differential equation means equation which involves the derivative or differential coefficient. Then two type of equation. Ordinary means the differential equation which involves ordinary derivatives, and partial means which involves a partial derivatives. Now after this we discuss the degree and the order of differential equation. What is the meaning of a order and the degree of differential equation? The order of the differential equation is the order of highest derivative appearing in the equation, and the degree is the power of the highest order derivative. So the order of the differential equation is the highest order derivative that involves in the differential equation, and the power of that highest order derivative is known as a degree of differential equation. So these two concepts are very complicated and very important, order and a degree. So order means highest order derivative that appears in the equation is known as a order, and highest order derivative power is known as a degree of that differential equation. For example, we have the equation dy over dx equals to x plus 3 cos x. So in this, dy over dx is highest order derivative. So the order of this derivative is 1, so order is 1, and power of this derivative is again equals to 1, so degree is also equals to 1. Now we discuss the second example, dy over dx equals to d square y over dx square cube plus 9y. Highest order derivative is 2, so order is 2, and the power of that is 3, so degree is 3. Now we discuss one more example, d cube y over dx cube plus 2 d square y over dx square raised to power 4 plus 5y equals to sin x. So we have the derivative of order, here the order is 3, here the order is 2. So highest is 3, therefore the order of the differential equation is 3, and now the power of this is 1, so degree is 1. So order means the highest order means the highest order derivative that involves in the differential equation, and degree means the power of that highest order derivative. So now we discuss the two standard forms of the differential equation, ordinary differential equation of first order and ordinary differential equation of second order. An ordinary differential equation of first order is the equation of the type f of x comma y comma dy over dx. That means the differential equation that involves x, y and dy over dx. Independent variable, dependent variable and first order derivative is known as an ordinary differential equation of order 1. And an ordinary differential equation of order 2 involves x, y, dy over dx and d square y over dx square. So the equation which involves x, y, dy over dx and d square y over dx is a ordinary differential equation of order 2. Now we discuss first we discuss the definition, then we discuss the types, then we discuss a order and a degree. Then we discuss two standard forms of a differential equation. Now we discuss the classification of differential equation. First we discuss linear differential equation. A differential equation involving the dependent variable and its derivative of first degree only. That means the equation which involves the dependent variable and its derivative only of a first degree, not higher powers or not a product of dependent variable and its coefficient is called a linear differential equation. So if we suppose y is our dependent variable and x is independent variable, So if the equation involves dy over dx and y only and not the product of y and dy over dx, that differential equation is known as linear differential equation. So this is the one of the standard form of the linear differential equation, dy over dx plus py equals to q, where p and q are functions of x only. So this is the one of the standard form of linear differential equation, dy over dx plus py equals to q, where p and q are functions of x only. So this is the definition of linear differential equation. Linear differential equation which involves the dependent variable and derivatives only in a first degree and not the product of these two. Now we discuss the non-linear differential equation. So it is a clear the equation which is not a linear is called a non-linear differential equation. So this is an example of non-linear differential equation, because in this the term d square y over dx square plus y square equals to 0. First of all, this is a derivative of second order, not of a first. So and this is a y square, because y into y is known as a y square. So this is not a linear differential equation. If the equation is not a linear, then it is known to be a non-linear. Now we discuss homogeneous differential equation. A differential equation of the form dy over dx equals to f of xy over fxy is known as a homogeneous differential equation. But the condition is that our function fxy and this fxy are the homogeneous function. Homogeneous function means the degree of function f of xy and f of xy is same. So if we discuss the example dy over dx equals to x square minus y square. So if we compare this with the standard form, this is our capital F of xy and this is our small f of xy. So if we check, the degree of a capital F of xy is 2 and degree of small f of xy is again 2. Power is 2, 2, x power 1, y raised to power 1. The whole power is 2. So the function, numerator function and denominator function both are homogeneous. So this is our homogeneous differential equation. After homogeneous differential equation, next we discuss the type is non-homogeneous differential equation. So the non-homogeneous differential equation is the differential equation which is not a homogeneous. So if the differential equation is not a homogeneous, then it is said to be a non-homogeneous differential equation. That means for a non-homogeneous equation, the function f of xy and f of xy are not a homogeneous function. That means the compiled degree or the total degree of the numerator and denominator is not equal. So the differential equation is known as a non-homogeneous. If we discuss, so for example, if we discuss dy over dx equals to x square minus xy plus y square over x minus y plus 1. If we check, our numerator term is x square xy plus y square. Power is 2, power is 2. Here again the total power is 2. But the denominator term x minus y plus 1. Power is 1, power is 1 here. The power of the variable is 0. So this denominator term is non-homogeneous. If this term is non-homogeneous, so our total equation become a non-homogeneous differential equation. So the behavior of a homogeneous or non-homogeneous differential equation is depend upon the behavior of the function f of xy and f of xy. So the differential equation, in this both the function are homogeneous, then the differential equation is homogeneous. Otherwise our differential equation is non-homogeneous differential equation, as we discuss in this example. Now next we discuss the exact differential equation. So the exact differential equation, a differential equation obtained by directly differentiating the function relation between x and y without any additional transformation. Here the without any additional transformation means without any addition, without any subtraction, without any multiplication or any other operation. Differential equation is obtained directly by differentiating a some function of x and y. That is known as exact differential equation. So these are the 5 types of differential equation. First is linear differential equation. Second is non-linear differential equation. Linear means the involves the dependent variable and its derivative in a first degree only. Non-linear, which is not a linear. Homogeneous, of the form dy over dx equals to f of xy over f of xy, where these two are homogeneous function. And non-homogeneous, which is not a homogeneous. And exact differential equation means which is directly obtained by differentiating the some relation between x and y without any additional transformation. So these are the some introductory part of the differential equation. Thank you.